All right, let's dive into something we all use every single day, but maybe don't think about enough, our water. We're going to use the North Carolina Hydrosphere as our case study to really get to the bottom of what makes our water healthy or not.
I mean, it's a simple question, right? But the answer? It's anything but. When you turn on that faucet, have you ever really stopped to think about where that water came from, what's in it, and the incredible journey it took just to get to you?
You know, this really gets to the heart of it all. It's a two-way street. We have a huge impact on our water and, in turn, that water has a direct impact on us. It's a cycle, and we're right in the middle of it.
So, to figure out just how healthy our water is, we kind of have to become detectives. Our first job? To look for the clues that are hidden right there in the water itself.
Exactly. Think of this whole thing like a forensic investigation. The water can't just tell us what's wrong, but it leaves behind a whole trail of evidence, these chemical and biological fingerprints that tell its story. We just have to know what we're looking for.
Okay, so let's start decoding. We're about to break down the main scientific clues that the pros use to check the vital signs of any lake, river, or stream. First up, our most fundamental clue, pH. You probably remember this one from science class, right? It's just a scale. 7 is neutral, like pure water. Anything below that is acidic, and anything above is basic. And believe me, that balance is absolutely critical for just about everything living in the water.
And here's why that balance is everything. See, on the left, healthy water systems hang out in that neutral sweet spot. It's where fish, plants, and all sorts of critters can thrive. But if it gets knocked out of balance, if it becomes too acidic or too basic, the entire ecosystem starts to feel the stress, and it can all start to fall apart.
Our next clue is turbidity. It's kind of a fancy word for a really simple idea. How clear is the water? If it's all cloudy and murky, full of dirt and sediment, then it has high turbidity. And that's a big problem. It blocks sunlight that underwater plants need to grow and can even clog the gills of fish.
Now for a super important one, dissolved oxygen, or DO for short. Think of it this way. Just like we need oxygen in the air to breathe, fish and other aquatic creatures need oxygen dissolved in the water. It's literally how they breathe.
And wow, the difference here is just night and day. On the left, when there's plenty of dissolved oxygen, you get a vibrant, bustling ecosystem. But on the right, when those oxygen levels plummet, you get what scientists call dead zones. And they're exactly what they sound like, areas where life literally can't breathe.
Okay, our next clues are nitrates and phosphates. In small doses, they're actually good. They're nutrients. But this is a classic case of too much of a good thing. When we get huge amounts of them from things like fertilizer runoff, they stop being nutrients and start acting like major pollutants, kicking off a nasty chain reaction.
And for our last clue, we're not looking at a chemical, we're looking at critters. Bioindicators are basically the canaries in the coal mine for our rivers. We're talking about tiny little river bugs, macroinvertebrates. Some of them, like mayflies, are super sensitive. If you find them, it's a great sign your water's really clean. Their presence or their absence tells you so much.
All right, so now we know how to read the clues. Phase 2 of our investigation, let's trace the problem back to the source. Where is all this pollution actually coming from? Who are the usual suspects?
So pollution pretty much comes in two flavors. First, you've got your obvious culprit. This is called point source pollution. It's easy to spot, like a big pipe coming out of a factory. But then you have the hidden suspect, non-point source pollution. And this one is way, way harder to pin down because it comes from all over the place. And seeing the examples really makes it clear. Up top, you've got your point sources, specific factory or treatment plant. But look at the non-point sources. It's everything that washes off our farms and our city streets when it rains. Fertilizers, oil, chemicals. It's this widespread, diffuse problem that is so much harder to control.
So let's connect the dots here with a critical question. What actually happens when all those nitrates and phosphates we talked about, the ones from farm fertilizer, wash into a river?
This table shows that devastating chain reaction I mentioned. It's called eutrophication. Look at the before runoff column. Everything's pretty balanced, but then check out what happens after runoff. The nitrates and phosphates go through the roof. This causes a massive algae bloom. Then, when all that algae dies and decomposes, the bacteria doing the work suck up all the dissolved oxygen. The DO levels just crash, creating one of those dead zones.
So, with all these different threats out there, how on earth do we end up with safe water coming out of our taps? Well, that brings us to the guardians of our water supply, the systems and the standards that are designed to protect it.
See, our water protection really stands on three big pillars. First, you've got constant monitoring, always checking for those clues. Second, strong legal standards, like the landmark Clean Water Act of 1972. You really can't overstate how important that was. Before it, barely a third of our nation's water was safe. Now, that number is more than double. And third, a really effective water treatment process.
And this is the incredible journey your water takes. First, chemicals are added to make all the little dirt particles clump together. Then, those heavy clumps sink to the bottom. After that, the water is pushed through layers of filters to catch even tinier particles. And finally, it's disinfected, usually with chlorine, to kill any lingering germs before it's sent on its way to your house.
That whole treatment process is amazing, but it's really the last line of defense. The true solution, the best one, starts way earlier. It starts with us, and with our role as caretakers, as stewards of this precious resource.
And honestly, this is the biggest takeaway. It's not just about fancy technology or government rules. It's about a fundamental shift in mindset. It's about understanding that we have a real responsibility to take care of the very thing that takes care of us. And let's never forget this crucial fact. All the fresh water we depend on, it's finite. There's only so much of it. We can't just make more. What we have is what we've got, which makes taking care of it not just a nice idea, but absolutely essential for our own survival.
So I'll just leave you with this final thought to chew on. A river or a lake isn't just a body of water. It's a mirror. It reflects the community living around it, our choices, our habits, our priorities. So take a look around. What does the health of your local water say about you?